let's look at some applications where we're using that probability density function. So for example 3, it says the following. Alex Incorporated manufactures a 200-watt electricity light bulb. Lab tests show that the lifespan of the light bulbs has a distribution described by the probability density function of f of x is equal to 0.001 e raised to the negative 0.01 t, where 0 is less than or equal to t, which is less than infinity. Part A, determine that a randomly selected light bulb will have a lifespan of 500 hours or less. So for part A, and that should say determine the probability. So this should say determine the probability that a randomly selected light bulb will have a lifespan of 500 hours or less. So if I'm trying to determine that probability, well, recall for that probability density function, we know if we want the probability that something's going to be between C and D, it's going to equal the integral from C to D of the probability density function. Well, I'm given what my probability density function is, so now I just have to find out what my interval is, what am I looking at, and that event is looking at the subset that is 500 hours or less. So for part A, if I want an event that's happening between 500 hours or less, I'm looking at the interval from 0 to 500. Therefore, I'm looking for the probability that this event is going to occur, and that should be in t's because my variable here is given in t's. So this should be a t. Apologize. So that should say a t because my variable is given in t's. So t is between 0 and 500. Well, that's going to be the integral from 0 to 500 of my probability density function, which is that 0.001 e raised to the negative 0.001 t dt. Well, again, just like the problems that we did before, we're going to need substitution for this. So if we let our u equal what e is being raised to, so if u is equal to negative 0.001 t, then the derivative, or my du, would equal negative 0.001 dt. But I don't have a negative 0.001 dt. I have a positive 0.001 dt. So I know I just need to divide out my negative to get this to look exactly the same. So this becomes negative du is equal to that 0.001 dt. So if I substitute in here now, I'm looking at the integral from t equals 0 to t equals 500 of e raised to the u, and don't forget your dt is equal to a negative du. Well, I know how to integrate that. That's just going to equal the negative of e to the u evaluated from t equals 0 to t equals 500. And what we're going to want to do is we're going to plug that back into t's and then put in our upper and lower limits of integration. So you're looking at negative e to the, remember t is equal to that negative 0.001 t, and again this gets evaluated from 0 to 500. So plug in your upper limit of integration, and you're looking at negative e to the negative 0.001 times 500. And then plugging in your lower limit of integration, so that would be minus, but minus a negative is plus, and that's e to the negative 0.001 times 0. And we're just going to do this on a calculator. So you're looking at negative, and then we're looking at e raised to the negative 0.001 times 500. And this gets added to e raised to the negative 0.001 times 0, which would just be 0, and that would just be 1. So we're looking at, this is going to be approximately 0.39, or it has a probability of 39%. So this is again going to be approximately 0.39, or you're looking at that probability of 39%. Well, that's part A. What about part B? What does that say? Well, it says, what's the probability that a selected light bulb will have a lifespan of more than 1,000 hours, but less than 1,500 hours? So now my interval has changed. So for part B, I want the probability that we are going to be more than 1,000, but less than 1,500. So this is just going to be the integral from 1,000 to 1,500 of my probability density function, which remember is that 0.001 e to the negative 0.001 t dt. And we're going to take a little bit of a shortcut here when we're working this problem out. Instead of doing this whole substitution again, we know how this integrated. If we just look at what we integrated here, when we integrate 0.01 e to the negative 0.01 t dt, it's always going to integrate as the negative of e raised to the negative 0.001 t. So I don't have to do the substitution for this. I did that in part A. I can just skip to what the integration is. And so again, I know that this is just going to be negative e to the negative 0.001 t evaluated from 1,000 to 1,500. Again, I don't need to do all this intermediate stuff that we did here because it's going to be the exact same thing because we're looking at the exact same probability density function. So then plug in your upper limit of integration. So we're looking at the negative of e raised to the negative 0.001 times 1,500. Plugging in your lower limit of integration, so minus, but minus a negative is plus, and then we're looking at e raised to the negative 0.001 times 1,000. And we're going to go to the calculator. And what I'm going to do on the calculator, since it's basically the same function that I had before, is I'm just going to hit second entry. And I'm going to change my upper limit of integration from 500, which is what it was before, to 1,500. So I'm just going to insert that 1. And I'm going to change the lower limit of integration, which before was 0, I'm going to change it to 1,000, which is what it is now, just so that I don't have as much to type in. So I get approximately 0.14. So this is approximately 0.14 or 14%. So the probability is going to be about 14% or 0.14. All right, let's look at the last one. Let's look at example 4. Example 4 says that the shelf life in years of a laser pointer battery is a continuous random variable with probability density function f of x is equal to 1 over x plus 1 squared if x is greater than or equal to 0, or 0 otherwise. So we're given, again, our probability density function and that interval that it's in, which is 0 to infinity. So now, find the probability that a randomly selected laser pointer battery has a shelf life of 4 years or less. Well, that's exactly what we did in part A for example 3. So we want the probability that we're going to be between 0 and 4. So that's going to be the integral from 0 to 4 of, well, between 0 and 4, I know that I'm choosing my top function here because that's where I exist if I'm between 0 and 4. So it would be of 1 over x plus 1 squared dx. Now I need to integrate this, so I know that I'm going to let my function that's being raised to a power equal u. So if I let u equal that x plus 1, then my derivative, my du, would equal to dx, which is perfect because that's exactly what I have. So this is going to equal the integral from x equals 0 to x equals 4 of 1 over, remember my x plus 1 became u, and then that gets squared still, and my dx became my du. So I know that when I look like this, I need to rewrite it before I take the integral. So this is going to be the same as the integral from x equals 0 to x equals 4 of u to the negative second du, because I don't know how to integrate division. But this is now just my power rule. Here my n is equal to negative 2. Therefore, this is going to equal 1 over negative 1, u raised to the negative first, evaluated from x equals 0 to x equals 4. If I clean it up and put my x's back in, I'm looking at the negative of 1 over, remember my u is my x plus 1 raised to the first power now, and this gets evaluated from 0 to 4. So let's plug in that upper limit of integration, so negative 1 over 4 plus 1, and then plug in that lower limit of integration. Well, minus a negative becomes a plus, 1 over 0 plus 1. So we could use the calculator for this if we wanted to, but this is just becoming negative 1/5 plus 1, which is 4/5, or that's 0.8, or 80%. So what does that mean for us? Again, it means that the probability that a randomly selected laser pointer battery has a shelf life of 4 years or less is about 80%. So what does part B ask us to do? Well, part B is saying, now graph y equal f of x from 0 to 10 and show the shaded region from part A. So it wants us to graph that 1 over x plus 1 squared. Well, f of x equals 1 over x plus 1 squared, I know is a rational function. And I also know that I'm only going to be graphing it between 0 and 10 because that's what I'm asked to do. So it's a rational function. I know that it's got a vertical asymptote at negative 1. And I know that because if I set that denominator equal to 0 and I solve it for x, I get x equal negative 1. So here at negative 1, I have a vertical asymptote. I know that I have a horizontal asymptote at y equals 0 because if I take the limit as x goes to infinity of 1 over x plus 1 squared, I would end up with 1 over infinity, which is just 0. So that I know that I have that horizontal asymptote at y equals 0 here. And then if I just do some function values so that I know what happens exactly at 0 and exactly at 10, well, in a calculator, if I figure out what 1 divided by 0 plus 1 squared is, I'd end up with 1. So when the x value is 0, the y value is 1. And then when x is equal to 10, let's figure out what y is. So this again is just going to be 1 divided by, in this case is now 10 plus 1 quantity squared. And I get something that's really close to 0.008. So when I'm at 10, so let's call this guy 10, I'm almost at 0, so I'm about there. So if I just connect those two dots, I know that this is the shape of the graph of f of x equals 1 over x plus 1 squared from 0 to 10. Now it wants me to show the shaded region for part A. So let's say that right here is 4. So what it's saying is to show that the area from 0 to 4 of this function under the curve represents there about 80% of what you would see. Part C says find D so that the probability of a randomly selected laser pointer battery D years or less is 0.5. So this question is different because what it's actually giving me already, it's giving me what the probability is. So it's saying that the probability from 0 to D is going to equal 0.5. So what I need to do is I need to find one of my limits of integration. Well, how would I do that? Well, again, I know that this is just going to be the integral from 0 to D of my function, which is that 1 over x plus 1 squared dx. And I know that the whole entire answer here would equal the probability of 0.5. So I need to find D. Well, how do I do that? Well, the first thing I need to do is I need to integrate this. Well, what is the integral of 1 over x plus 1 squared dx? Well, I already figured that out. in part A, right? I don't need to do the u sub and do it all again. I figured out that the integral of 1 over x plus 1 squared dx is just that negative 1 over x plus 1. So I'm going to skip to that portion. So I know that negative 1 over x plus 1 evaluated from 0 to d should equal 0.5. So now, just like before, I'm going to plug in my upper limit of integration. So negative 1 over d plus 1 minus, plug in your lower limit of integration. Again, minus a negative is a plus, and this is going to be 1 over 0 plus 1. And I know that the answer here is still going to equal a half. Well, this is actually enough information to solve for d, so let's try to combine as much as we can with the numbers and simplify this as much as we can before we solve for d. I'm going to leave the left alone for right now, negative 1 over d plus 1. But I know that 1 over 0 plus 1 is just going to be 1. Now, if I subtract 1 from both sides to solve for d, because you're going to want d all by itself on one side of the equal sign, I'm going to end up with negative 1 over d plus 1 is equal to, well, 0.5 minus 1 is a negative 0.5. And then I might also notice that both of those are negative, so I can cancel the negative out from both of them. And then in order to solve rational equations, since you have a single fraction over here equal to a number, you set this number over 1 and you cross multiply. So I get 0.5 times d plus 1, and then I'll fix it or distribute in a second. And then 1 times 1, which is just 1. So let's go ahead and distribute now. Well, 0.5 times d is 0.5d. And 0.5 times 1 is 0.5. And that's equal to 1. So now subtract off that 0.5 from both sides, and I get 0.5d is equal to 0.5. To solve for d, you need to divide by 0.5, so d is equal to 1. So that means that d has to be 1 year so that the probability would be 50%. So d would have to equal 1 year. That's it for section 6.2.